Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. Thanks for the time. Before I present our research, let me introduce myself. My name is Putri Amalia Devianda, and the title of our research is Measurement of Vapor-Liquid Equilibrium for Binary Systems, Limonene and Citronellal in Kaffir lime essential oil as antimicrobe substance. This is our outline, introduction, materials and methods, Ebiometer Validation, consistency test, vapor-liquid equilibrium correlation, vapor-liquid equilibrium prediction, and conclusion. Introduction. Indonesia has some natural resources. There are 400 types of fruits in Indonesia. For example, Kaffir lime. Kaffir lime has a strong international market with its breeding center located in Batu City, East Java. For increasing the economic value of Kaffir lime, previous research showed that Kaffir lime has antimicrobe substance. The main component of Kaffir lime leaf is Citronellal, can be antibacterial and anti-cancer. And the main component of Kaffir lime peel is limonene, can be absorbed quickly in the gastrointestinal tract. Their previous research for the first Batuta et al. In 2020 for the binary system ethanol plus glycerol and propanol plus glycerol use modified Ebiometer glass Ortmirtil type, and their Chen et al. In 2011 and 2013 with binary system Citronellal plus Citronellal, but it just gives experimental data for liquid phase and vapor phase. So there is no binary system of limonene and Citronellal. So vapor-liquid equilibrium data of limonene and Citronellal are required for various separation processes in industry. Okay, next, materials and methods. Okay, there are two materials we needed. For the first, limonene, this is the properties, and then for the second, Citronellal with its properties. Okay, this is for liquid equilibrium experiment equipment series. For the first, cooling water through the condenser and then insert the Ebiometer cell with a mixture of binary system in various composition, turn on magnetic stirrer, turn on heater and vacuum pump, and then until equilibrium, rate indicator, temperature indicator for of T2 and T1, and then take the sample of liquid in C1 and take sample of vapor phase in C2. Okay, this is specification of gas chromatography for our research. The type of column DB5, and then carrier gas nitrogen, detector FID, for configuration, temperature 60 until 200 130, and then the rate 10 Celsius per minute, speed ratio 30, and then airflow 350, makeup gas flow 45, and hydrogen flow 35, and the time of analysis is 23 minutes. Okay, for the next, Ebiometer validation. Ebiometer validation using Limonene and Citronellal and thermocouple calibration by boiling and freezing point of water. In validation, we can get average absolute deviation temperature of limonene 0.2 Celsius and average absolute deviation temperature of citronellal we can get 0.61 Celsius, and then for calibration we can get boiling point of water is 100 Celsius, and for freezing point of water we can get 0 Celsius. Okay, this is the graph of vapor pressure data of limonene with the average absolute deviation temperature is 0.2. And this is a vapor pressure data of citronellal with average absolute deviation temperature 0.61. Next, consistency test. Okay, this is experimental data of limonene and citronellal at 20 kPa and 40 kPa after analysis by gas chromatography. Consistency test of experimental data by using Wisniak with the value of L per W is more than 0.62 and less than 1.8 with deviation or D is less than 5. So the binary system limonene plus citronellal at 20 and 40 kPa consistent. And then VLA correlation, formula of Wilson, Anartel, and Unicode for coefficient activity. This is an interaction parameter of binary system with average absolute deviation temperature is 0.13, and then for limonene plus citronellal at 40 kPa is 0.15 and 0.48. Okay, this is vapor liquid equilibrium data for the binary system of limonene and citronellal at 20 kPa with experimental data combined with calculation by modeling Wilson, Anartel, and Unicode. And then it's like previous slide with experimental data and calculation coincide. Next, vapor liquid equilibrium prediction. For prediction, we use unifact model with this formula, and then this is a comparison of diagram prediction for binary system Limonene and Citronellal at 20 kPa, and then this is for 40 kPa. Okay, for the last conclusion. Okay, the conclusion is research that has been carried regarding the measurement of vapor liquid equilibrium for the binary system Limonene and Citronellal at 20 kPa and 40 kPa with Ebiometer Validation using pure compounds show a very good correlation result from the Wilson and RTL and Unicode models based on parameter interaction with average absolute deviation obtained 0.13 and 15 and 48. However, the prediction results using the UNIVAC model are not satisfactory at 40 kPa, so prediction modeling may not necessarily be applied to experiment. Okay, I think that's enough, so thank you.